Okay. Go over a few problems from the quiz where these were the most requested questions. The first one was number 8 was one of the most requested ones, where it gives you that the magnitude of R is 13 and the magnitude or length of vector S is 20. And then the angle between them is 84 degrees. So when they tell you the angle between, you need to put their two tails together. So if I say, let's say that's R, and its magnitude is 13, and then S, I'm just going to make it horizontal just to make it easy, is 20, and then this angle in between them is 84 degrees. And then it's asking you to find the the magnitude of R plus S. Well, because they gave you the angle between, you had to put the two tails together like this. So you have to do this using the parallelogram method, where if I'm continuing this parallelogram, then that means this side is also 20 and this side is also 13, since opposite sides are congruent. And then the R plus S is going to be from the tail here to the opposite corner. It's that one. That would be R plus S. Okay. I know this vector is cutting through angle 84, but we don't know how. Like, it doesn't cut it in half. You can't tell how much is this angle and how much is this angle right away, right? You can't just go, oh yeah, it's 42 degrees. No. Instead, what you need to do is to find R plus S, I need this angle here, because then I would have a side angle side triangle. But we know that if this angle is 84 degrees, then this angle here, these two angles in a parallelogram add up to 180. So this angle here is 96 degrees. And so I can find R plus S, this magnitude, by doing law of cosines. It's this guy squared would be side squared plus side squared minus 2 times side times the cosine of 96 degrees. It's this guy squared, so I'm going to do, this is the square root of that whole thing. And so that ends up giving me, no, I'm trying to push clear. Come on. All right, so we got square root of 13 squared plus 20 squared minus 2 times 13 times 20 times the cosine of 96 and 24.967. 24.97 would be the answer I would give, rounding to the nearest hundredth. Now I'm going to use this value. So if your numbers were off a whole bunch, or by a little bit on every single answer, it's because you're not storing. You need to store this answer. So I stored it under A, and I'll write that to myself. I stored it under A. Okay. The other thing they want is the angle that the R plus S is the resultant, and they want the angle it makes with S. So the way I drew this, I want this angle here. In there. That's the angle I want. I'll call it theta. You won't have an issue with, whatever. Okay, so you can use law of sines. Yeah, even though I have a, you can use law of sines. All right, so I would have sine of theta over 13 is equal to sine of 96 degrees over this stored A value. And then to solve for that, you would multiply both sides by 13. And then you would have sine of theta equals that. And then you need to take the inverse sine of both sides. And that's what will give you theta. And when you put that in, inverse sine of 13, sine of 96, and the parenthesis divided by my stored A value, and I get 31.187. And so that rounds to 31.19. Going degrees. Yeah. Okay, so that was 8. That was the R plus S was this, and the angle it made with S is that. All right. The other question you guys had, many of you had, was number 10, and that's the bearing. And yes, 10 is the bearing problems are usually the ones that give you the most problem. So it says an ant crawls 10 inches at a bearing of 210 degrees. So 10 inches is its magnitude of the vector, and then the bearing is 210. So you're going to start by drawing a north, south, east, west. You can do it straight lines, whatever. Okay, so there's your north, south, east, west. A bearing of 210. You're going to start from the north, go clockwise, 90, 180. What do we want? 210. So I'm going to go 30 more right there. So that's 210 degrees. And I'm going, how far did it crawl? 10 inches. Right, so there's 10. And then it changes direction. So right now the ant is sitting at that spot right there, but now it changes directions and it turns and it has now a bearing of 315. So you're going to draw a new north, south, east, west at this new spot. Here's your new spot. Going 310 degrees, this would be 90, 180, 270, and we want to go to 315, which would be there. And we want to go, how far? 18 inches. You want to try to be kind of sort of proportional. If I'm making this 10 and the next one is 18, I need to go 10 and then, so almost double this length. It's not a huge deal if you don't, but you can confuse yourself. If let's say you made it go to right here, you would think, oh, that's a 90-degree angle and I can find it that way. So that's what I mean by try to kind of sort of be proportional. If that's 10, it's almost twice the length of it would be 18. Okay. And then they want the displacement vector as a magnitude and a bearing. So that's two different answers. Magnitude is the length of this vector, D. I want to know the length of that vector. That'll give you the magnitude. The bearing will be from the north going around. I went to 210 and I'm going to keep on going until I reach D. All right, so let's start with the magnitude. The magnitude. Okay, so to get this guy, I can find it using law of cosines. If I can find the angle and the triangle right there, which I can, you're going to pretty much use the same thing every time. Two parallel lines cut by a transversal. The north-south lines are like this. I've got a transversal going through them. Here's the north-south line. Here's the north-south line. Transversal is this guy. I know what this angle is because this is 210, but from here to here is 180, which makes this guy 30. So if that's 30 degrees, so is this angle. So this guy just to the north-south, just to this straight line, that part's 30. And then I can also find the angle right there because from the north-south to here was 315. If I went all the way up to the north-south line, it would be 360, which makes this guy 45. And so together, adding those two up, this angle here is 75 degrees inside that triangle. Hopefully that made sense. You're pretty much always going to use two parallel lines cut by a transversal. You just got to find what part it is. And in this case, you had to add the two. Sometimes that happens. Anyway, so my D squared, using law of cosines, is equal to 10 squared plus 18 squared minus 2 times 10 times 18 times the cosine of 75 degrees. And so you'll take, D will be the square root of that whole thing. And I'm going to use it, so I'm going to store it. It'll be the square root of 10 squared plus 18 squared minus 2 times 10 times 18 times the cosine of 75. And you end up getting that D is about 18.188. So I would say 18.19 inches. Now I'm going to need that value, so I'm going to store it. Stored under A. All right. So now, how do I find the bearing of this resultant vector? We'll do it in a different color. The bearing will be starting from the north, coming around. That's 90. That's 180. Right there is 210. That's important. I'm going to keep on going, though, to reach until I reach this displacement vector there. So that's going to be my bearing, right? Well, I knew as I went around 90, 180, right to here was 210. So if I can find, which I can, if I can find the angle inside of this triangle, the bearing will be 210 plus this little angle here. So I'm going to call it theta. And I'll find it. And then the bearing for this problem, it'll be 210 plus that angle. All right, so finding the angle, I can use law of sines. Sine of theta over 18 is equal to sine of 75 degrees over that stored value that I just found for the displacement. It's the 18.19, right? But if you put 18.19 in there, you're going to be off. Your answer will be off. So to solve for theta, you would need to multiply both sides by 18. And then take the inverse sine of that whole thing. And that's what will give you theta. So I go inverse sine of 18, sine of 75, and that parenthesis, or else your answer will be off, divided by my stored A value. And I get theta is about 72.92 degrees. Warning for you, that will be one of your multiple choice answers. So keep in mind when you solve for this theta, that's not the bearing. That was the angle inside of the triangle, right? And it's a common error for you to go, oh, I'm done, theta. That's the calculator answer. That's my answer. No, 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 no. The bearing is 210. Remember, it's starting from the north, going around, we hit 210, and then we have this angle. So it's 210 degrees plus the 72.92 degrees. And so you should have gotten an answer of 282.29 degrees. That's the bearing for this problem. Keep in mind that not always are you going to be adding it. Sometimes we subtract it, right? So how do you know? It depends on the picture. That's why I say try to do it proportional. So if I had done instead, let's say he had gone down this way, right? But then let's say instead of going up, what if he went this direction instead, right? So let's say this was the 210 degrees, and then let's say he had gone, I don't know, whatever that was, right? Your resultant vector would be this one. This is what would be D if he had gone and went, you know, southeast instead of he went northwest once he hit this spot on the actual problem. But what if you went this way? Well, look, now your bearing is to there. All the way around is 210. So when you find this angle theta inside here, let's say we call it theta, right? That angle. For this problem, your bearing would actually be 210 degrees, but you stop short, so minus the theta. That's how you know if you're adding or subtracting that angle inside. It just depends on the problem. It depends on where is that displacement vector in relation to the original bearing. So draw your picture, try to stay proportional. and you won't have an issue. Someone had asked magnitude and bearing. Why is it one problem? One answer. It's not actually. It's two answers. It's, you know, this was the magnitude of the displacement vector. It's the length of how long it is. And then this was the bearing. The bearing is the angle going from the north, going clockwise until you hit that vector. So two different answers. A lot of times your book will give it to you as, oh, it's 18.19 inches at a bearing of 282.29 degrees. So they put it as one answer, but it's really two. And so you'll have it separated. Okay, so those were the most asked questions. The other one was, lots of people asked for 4 and 5. So for 3, 4, and 5, how do you tell how many triangles? There is a formula in pre-calc. We give you, you know, the book has this, like if A is bigger than B, sign of, like there's this whole formula that you could plug in and find it. I hate memorizing. It's gibberish to me, right? And so I don't memorize that. What I do in solving questions 3, 4, and 5, where it says state if one triangle exists, 2 or no, I just start solving it. And once I get my answer or answers, then I say how many triangles there are. So I work backwards on it because I don't like to memorize. So for number 4, it was triangle XYZ. I do always draw the picture because to me, it makes sense. It doesn't make sense to just start plugging crap in where you don't know. So this time they gave you side X, side Y, and angle X. Definitely a side angle, pain in your butt triangle, right? And so you just keep in mind that when you are given angle side, ASS, when you're given that, right, it's a pain in your butt. You need to be aware of, I could get no triangle, I might just get one, or I might end up with 2. So number 4, when you go to use law of sines, they asked you to find side Z. The problem is you can't go straight to finding Z until you have angle Z. And there's no way to find angle Z. You have to find angle Y first. There's no other choice. Even though they asked for side Z first, there's no finding that. You've got to find angle Y first and then find angle Z and then find side Z. So sine of angle Y over 10 is equal to sine of angle X over side X. And you go and you solve, and it's a inverse sine of 10 times sine of 31 degrees all over 4, because I multiplied by 10, and then I took the inverse sine. And when you put that in your calculator, inverse sine of 10 sine of 31, and the parenthesis divided by 4, domain error. All right. You may want to double check that you did it right, you know, maybe plug it in one more time. But why did it give me domain error? Well, let's see. 10 sine of 31 divided by 4 is 1.28. And sine values are always between +1 and -1, never bigger. So that's the reason why you get a domain error. What does that mean? There is no triangle exists with that given information. So that's when I say, oh, there's no triangle, right? I didn't know until I got this domain error. And so then for Z equals what? I just, no, there's no value for Z because there's no triangle. Number 3 obviously was the one triangle one, right? You go and you solve it, and there was only one triangle. When it was a side. So you just use law of cosines. The only time that there's a possibility of no or 2 is when it's the law of sines, when it's the pain in your butt one, angle side, right? Okay, so for number 5, sure enough, they gave you a pain in your butt one. And it was triangle STR, where side S is 12 and side T is 15, and angle S is 26 degrees. Angle side, pain in your butt. So you're aware of it, right? You're looking at it going, okay, this could possibly have two answers. And how do you find out? All right, well, let's work on this one first. You can't find, what they want you to solve the whole thing. Okay, you can't find any information about R yet or side R. The only thing you can find, because they gave you side T, is angle T. So I'm going to find that first. Sine of angle T over 15 is equal to sine of 26 degrees over 12. And you solve for T and you get, you would multiply both sides by 15 and then take the inverse sine of it. So angle T is what? Inverse sine of 15 sine of 26 divided by 12. Angle T is 33.23 degrees. But this was an angle side one, right? So you're going to go or, right, 180 minus that angle, 146.77. So it's a or 146.77. Now, do I know both of them exist yet? Nope, not yet. I don't. So here's what I'm going to do. I'm going to draw a second triangle just in case. Whoops, I smeared it. Now, what stays the same, STR, my given information stays the same. S is still 26 degrees, side S is still 12, side T is still 15, right? But what's different, if this second triangle exists, and I don't know yet, right? If it exists, then this guy is 146.77. This one was 33.23. Yeah. So if it exists, then that's 146.77. How do I know if this second triangle exists? Because when you go to find angle R, which would be next, angle R would be 180 minus the 26 they gave you and minus this possible angle T that we just found, right? And so you go 180 minus 26 minus 146.77. And if I get a negative angle for R, the second triangle does not exist, right? You just got one answer. You only have one triangle. But if I get a positive angle right now for R, then two triangles work for this given information. And I do. I get 7.23 degrees. So that's what would go here, 7.23 degrees. So I definitely have two triangles. How do you find this R? Well, remember these three angles add up to 180. So come back over here. R would be in this triangle, it's 180 minus the 26 and then minus the T we found, 33.23. And that will give you 120.77. All right. So definitely two triangles exist. This is the information so far. We still need to find side R, and it'll be different for each of them. This is an obtuse angle, so side R better be bigger than both 15 and 12 because it's the largest angle. This one is 7.23, so it's the smallest angle out of the three, so it better be smaller than both 15 and 12. Better be, or else you did something wrong. So how do you find side R? You're going to use law of sines. Side R over sine of, for this triangle, it's 120.77. And that's equal to, use the information, don't use your approximated answer, use the solid answer they gave you, which was 12 over sine of 26 degrees. And so this will be R is equal to 12 times sine of 120.77 over sine of 26. Let me put that in. 12 sine 120.77 and the parenthesis divided by sine of 26, and you got 23.52. Or over, if it was this triangle, the second one, your R would be, whoops, R over sine of 7.23 degrees is equal to 12 over sine of 26 degrees. And so when you solve for R, it'll be 12 times sine of 7.23 over sine of 26, which will give you 3.45. So that's how you tell if there are one. Now, and then this is where, once I figured out, oh, look, both of them worked, that's when I say, oh, this one has two triangles on that blank of, how many triangles. I solved it first. I came up with, oh, there's two triangles that work for it. And so then that's when I say it. One more thing, because I think the multiple choice answers on the test will be in degrees, minutes, second, or degrees and minutes instead of decimals. Remember, let's do this one right here, right? Because angle T was inverse sine of 15 sine of 26 divided by 12. Okay. So here was your decimal answer that I got for angle T, right? So how do you tell what are the degrees and minutes instead of decimal degrees? I didn't teach you the way to do it by hand. I showed you how to do it on your calculator. You hit the degree, minute, second button. You see degrees, minutes, seconds. That's radians. That's gradients. You could arrow all the way to the right, or the quicker way is go one arrow to the left, and it says DMS. You're not sliding into anybody's DMs. No, that's degrees, minutes, seconds. Hit that, and then enter again. And it changes 33.23 degrees to 33 degrees and 13 minutes. Actually, there are 60 seconds in a minute, right? So half of a minute would be 30 seconds. So if your seconds are over 30, you would round up that minute. So this answer will be 33 degrees and 14 minutes as an answer. Just hit your degrees, minutes, seconds, and you'll see. So hopefully that makes sense. Okay, I hope that helped. Good luck on the test. I'm sure you all will do fantabulous for sure. All right, have a good day.